Okay, here's our review for Chapter 5. So, what have we learned this semester? Well, this section. Well, we really haven't learned anything new except a couple of formulas. So, let's just write those down. Derivative with respect to x of the natural log of x equals 1 over x. Or the derivative with respect to u, the natural log of u is 1 over u. Okay. Therefore, the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. So those are the two that match up there. We have that the derivative with respect to x of e to the x is e to the x, and the integral of e to the x dx equals e to the x plus c. We have the derivative with respect to x of log to base a of x, and we end up with 1 over the natural log of a times 1 over x. So basically what we do here is use the change of base formula, which would say that's the natural log of x over the natural log of a, and that's how you get the 1 over a part, and then you just do the same thing as up here. So, and we don't need to know how we did that. So there isn't really an opposite one of this, because you just, if you have 1 over x, you just deal with the natural log of x. I mean, you could theoretically put it back into a different base, but typically you just stay in the base C base. Okay, so what else we got left here? We've got the derivative with respect to x of a to the x, and that is, I think it's the natural log of a times a to the x, if I remember correctly, but I'm going to look at my sheet here. It's equation 12, natural log of a times a to the x, and then you've got the other way around. The integral of a to the x dx is 1 over the natural log of a to the x plus c. So those are all the ones that involve logarithms and exponential functions. And then I'm not going to write them all down, but we've got the derivative with respect to x of all the arc trig functions. There'll be 6 of those, and then there are 3. So make sure you write all 6 equations down hard. Then you have the integrals. There's only 3 of those, which is 1 over a squared square root of a squared minus x squared dx. That is the arc sine, or the inverse sine, of x over a plus c. The integral of 1 over a squared plus x squared dx is 1 over a arctangent of x over a plus c. And then the final one is the integral of 1 over x times the square root of x squared minus a squared dx is equal to 1 over a arc secant of the absolute value of x over a c. Okay, so those are the formulas. The rest of it is basically using all the stuff we've learned before. So we need to know how to use the product rule. Theoretically, I would ask you to know the quotient rule, but I'm not going to have you worry about it. You need to know how to use the chain rule. So let's just write down what these are. And I'm going to rewrite the product rule as words. We talked about that in class Y. So the product consists of 2 parts, the first part of the product, the second part of the product. So the product rule says the derivative of a product of 2 terms is equal to the first term multiplied by the derivative of the second term plus the derivative of the first term times the second term. And the reason it is in words is just because when you have a product, you know, do I call it f of x, g of x, h of x? It's confusing, but if you just call them first term and second term, then you'll be fine. Now, the chain rule, of course, is you pick something to be u of x. You have a composite function, and you have to identify part of it as f of u and part of it as u of x. So the chain rule is f of u of x. So usually the u of x part is the argument inside whatever. In the past, it's been parentheses, raised to a power, square roots. In this chapter, it could be u of x, could be what's inside the argument for the logarithm function. The x could be the exponent of the exponential function. It could be the argument of the inverse trig functions. So you take this, which is a function of x, you take the derivative using the rules that we know. F of u is a simplified version, and we can do that. So we do, you know, we've set up this arrangement where we calculate f of u, u of x, and we take the derivatives of each one. And then the chain rule says that f prime of x is f prime of u times u prime of x. And then we have to substitute in for u, take that value, plug it into whatever the u is in this case. And then you simplify it appropriately. So the chain rule and u substitution. So we've done a heck of a lot of that, so I'm not going to belabor on that point. There's two other things that you need to review because they're going to be on the test. Is finding an equation for tangent line. We haven't done that for a while. I think it's been in your homework, but so what you do is you have some function f of x is something, and I'll make something up here. Let's say it's e to the x plus the natural log of x. Let's make it something other than just, let's make it the natural log of x plus 2. Okay, so what I want to do is find the equation of the tangent line. At x equals 1. Actually, let's do it at x equals 0, just to make this easier. So, first thing you do, to define an equation, you need to know the slope, and you need to know 2 points. So I know 1 point, x equals 0. So I need to find the y value. So I do f of 0, which would be e to the 0 plus the natural log of 0 plus 2. So that's e to the 0 is 1, and then you'd have the natural log of 2. So it's 1 plus the natural log of 2. I'm just going to leave it as that. So that's the y value. So this y equals 1 plus natural log of 2. Then you have to find the derivative. So we have to find the value of the derivative. So first you have to take do the differentiation to do the derivative. So the derivative of e to the x is e to the x. The derivative of natural log of x plus 2 is 1 over x plus 2 times the derivative of this. This is using the chain rule in this one. Well, the derivative of x plus 2 is just 1. Derivative of x is 1. Derivative of 2 is 0, so it's just times 1. So I get e to the x plus 1 over x plus 2, and that's the derivative of the slope of the tangent line at any point. So now we look at it to evaluate f prime of x at x equals 0, because that's the point that we're dealing with. So if we do that, f prime of 0 is going to be e to the 0 plus 1 over 0 plus 2, which is going to be 1 plus 1/2, which is going to be 3/2. So that's f prime of 0. That's also the slope. So now we have the slope, and we have 2 points. We have 1 point, but the 2 coordinates. So then you write down the point-slope form of a linear equation. You plug it in. So the y minus, this is the y1, that's the y value. So we have 1 minus 1 plus the natural log of 2 is equal to the slope, which is 3/2 times x minus x1, which is 0. That's x1 right here. Okay, so now we just solve for y. So you're going to get y is equal to 3/2 x plus 1 plus the natural log of 2. And that's your answer. That's the equation for the tangent line to the tangent line to this curve at x equals 0 and y equals 1 plus the natural log of 2. Okay, so now that's one thing you probably haven't done for a while, and I want to make sure you understood about that. So I'm just looking through this. Yeah, I mean, there's nothing big surprise. So I'm just going to work a few. For example, if I give you a product, let's say f of x equals e to the x times x cubed plus 1. What is f prime of x? Well, this is a product. The product rule says that the derivative of the product is equal to the, let's see how I wrote that. The derivative of the product of 2 terms is equal to the first term multiplied by the derivative of the second term plus the derivative of the first term times the second term. So, that's actually pretty much it. You'd probably want to get rid of these parentheses, so you'd have 3x squared e to the x plus x cubed e to the x plus e to the x. So I could factor in an e to the x probably. So I'd have, let me order them, x cubed plus 3x squared plus 1. Okay, so you could simplify that a little bit. Okay, so the product rule. Let's say I gave you something that looks like this. So it's not a product, and it is a quotient, but when you just have a constant in the numerator, you really want to use the chain rule in this case. So the chain rule says you pick something that's in the parentheses, which in this case is the natural log of x plus x squared, and then you rewrite the original function as a function of u. u being this thing. So this becomes 7 over u cubed, or 7 times u to the minus 3 power. So that's f of u. This is u of x. If I plug this into there, I'll get back to the original function. So the chain rule says you take the derivative of this with respect to u. So it's just a power rule thing. So you get negative 21, negative 3 times 7, u to the minus 4. And u prime of x would be 1 over x plus 2x. So the chain rule says f prime of x is f prime of u times u prime of x. And f prime of u is, I'm going to rewrite this before I plug it in. I'll move that negative to the denominator. So it's going to be negative 21 over u to the 4th. That's u, f prime of u times u prime of x. And then this final step in the chain rule is to plug back in what u is equal to. And we go up there and look. Natural log of x plus x squared. Right, then we're going to raise it to the 4th power. And then we multiply by 1 over x plus 2x. Now I could combine this into a single fraction. So let's do that, negative 21 times. So what we'd have is, we want to have a denominator of x. So that term is 1 over x. And then we multiply both the numerator and the denominator by x. So I get 2x squared. So that would be the answer. Okay, so the product rule, chain rule. Now, we've got 3 different kinds of logarithmic differentiation, just straight logarithms. You know, if we have the logarithm of x to the 5th plus x to the 4x or something like that, and so that's f of x. You know, what is the derivative of that? Well, use the chain rule. For these cases where you have the natural log, just the natural log of something, it's easier just to think of it is you take the 1 over the argument, so that's 1 over u, and then you multiply it by the derivative of the argument. So that's it. I mean, I could have, the longer way would have been saying f of u is the natural log of u, and u of x equals x to the 5th plus 4x. And then I do f prime of u. F prime of u would be 1 over u. U prime of x would be equal to 5x to the 4th plus 4. And then you multiply these two together, substituting in u, and you get the same result. Okay. The second case is where the natural log is not just a single term, but is some complicated, more complicated situation. Like that. So we start with the natural log, but it's not just the natural log of one thing. It's got all these terms. So you use the properties of logarithms to break this apart before you take the derivative. So I've got this multiplied by that, divided by that. So you get the natural log of x squared plus 2 to the 4th plus the natural log of the square root of x plus 5 minus, because this is in the denominator, the natural log of x minus 3 cubed. Okay, then if we have exponents now, after we've broken it apart initially, we can move the exponents out front. So this is to the 1/2 power, so I bring 1/2 out. Here's the 3rd power. And once you've simplified it as far as possible, breaking apart the products and the quotients and brought the exponents that are applied to the whole thing out, then you would take the derivative. So the derivative here, you've got your constant 4. You take 1 over the denominator is the argument of the logarithm. The numerator is the derivative. So the second one, after you take the derivative of the natural log, it's over, the denominator is x plus 5. The numerator is the derivative of this, which is just 1. And then you've got the third one, which is the denominator is x minus 3. The derivative of this is 1. And then you can kind of clean it up at the end. 4 times 2 is 8. So you get 8x over x squared plus 2 plus 1 over 2 times quantity x plus 5 minus 3 over x minus 3. That's it. Okay. Then we have the case where you don't start out with the natural log in front of everything, but you do have a complicated expression here. So we want to use the properties of the logarithms, but it's not originally a logarithm, so you take the logarithm of both sides. And the next couple of steps are basically the same as the previous problem. So I'm just going to tell you what the answer is. So if you take, well, we haven't taken the derivative yet. We've got to break this up. So you're going to end up at 1/2 natural log of x squared plus 1 plus 2 from this exponent, the natural log of x plus 5 minus 3 from the exponent, the natural log of x minus 2. Okay, so this is all just modifying the original equation. We haven't taken the derivative yet. So now we take the derivative. When you have the natural log of y on the left-hand side, you have to use implicit differentiation. So you get 1 over y, which is a normal the case, but you multiply by y prime. And then we do all these, so you get 1/2 times, you put the argument of the logarithm in the denominator, you take the derivative of the argument, the derivative of this is 2x, then you have 2 times 1 over x plus 5 minus 3 times 1 over x minus 2. So this is the differentiation process. And finally, the final answer, y prime, you're going to multiply both sides by y to solve for y prime. And you'll clean it up so you notice these two cancel out. We'll get x over x squared plus 1 plus 2 over x plus 5 minus 3 over x minus 2. So that's the whole right-hand side. And then we multiply by y. So we have to rewrite y back down in terms of x. And that's as far as we're going to go. We're not going to combine these two, just get it to that point. So those are the three main kinds of logarithms, derivatives involving logarithms. Okay. Now, as far as integrating, what has to happen is if you have something like this, I have to give you the problem where this is going to be some constant times its derivative. So I'm showing you how I might make up the problem. So I make sure this is 2x plus 1, which is the derivative of that. I'm going to multiply by 2. So I probably would give you the problem 4x plus 2 over x squared plus x dx. So because there is no, You know, you might get this confused with the inverse trig function thing, but I don't have x squared plus a squared. And the first thing you always want to try is see whether it fits a logarithm. If you've got some like a quadratic term in the denominator, or just even it's a single term. But so you would try it and see if it works. So I would say, okay, well, let me try the whole denominator as being u. So if I do that, I'll get du is 2x plus 1 times dx. What I need here, well, you know, what I could do, I've got this common factor, so I could factor out the 2 to start with, and I'd get 2x plus 1, and then it would fit exactly. That would be one way of doing it. The other way would be saying, okay, I need 4x plus 2 dx, so I'd have to multiply both sides here to get 4x plus 2. And then I can make that substitution into here. So if I do that, I'll get, let me just do it this way, I would get 2 du divided by u. And I could factor out the 2, and then I have this formula. I have this in a form where I can just use the natural log. So it'd be 2 times the natural log of the absolute value of u plus c. And then u substitution says you go back and then substitute u back in. Of course, you have to substitute back in when you are doing indefinite integrals. If you're doing a definite integral, what you would do is change the limits and just keep it in terms of u. And then we have the inverse trig function. So be able to take a derivative of an inverse trig function. So I'm not going to actually work it out, but you know, let's say we have the arc cotangent of 2x. What is the derivative of that? Well, you would use the chain rule. So what we would do is we would break this up into f of u, which would be the arc cotangent of u, and u of x would be equal to 2x. So f prime of u would be equal to negative 1 over 1 plus u squared from the formula. U prime of x is equal to 2. So f prime of x is f prime of u times u prime of x. You get negative 1 over 1 plus u squared times 2. And then you would plug u back in, so you get negative 1. Well, we'll put the 2 in the numerator completely. 2 times 1 is 2. You get 2 over 1 plus 4x squared. Okay, so that's how you handle the derivatives of the inverse trig functions. You know the formula, you know the chain rule, that's it. And then we have the integrals of trig functions, and we've been doing that in class. So, you know, just there's going to be a case where you probably might even just be able to do it by observation if you're good at it, as far as doing the integral. There are some definite integrals involved with the inverse trig functions. You know, so if I gave you something like this, let's say from 0 to 5 or something like that. So you would say, oh, it's an inverse trig, that's an arctangent. So I would have to redefine my limits, which in this case actually you don't have to because u is x. So the limits would the u limits are the same as the x limits. So what I would have is I'd have 4, which is the coefficient here, times the integral of du over a squared plus u squared. And so I'd get 1 over a times the arc tangent of u over a between u equals 0 and u equals 5. Again, because of this substitution, if I had something like 2x or 4x squared, then I would have to change the actual numbers, but in this case you don't have to. So then you have 4 divided by 5, which is A. A is 5. So you get 4/5. And then you would have the arc tangent of 5 over 5 minus the arc tangent of 0 over 5. And the arctangent 0 is 0, and the arctangent 5 of 1 is square root of 2 over 2. I guess you can just plug into your calculator. I don't expect you to remember that, but and then you could simplify that. So it'd be 2 square root of 2 over 5 would be the answer. So there'll be one that's reasonably simple like this, but then there'll be 2 that will involve things that we did in class where we have to use completing the square. So you've done that. And one will be an indefinite integral, will be a definite integral. Make sure you know how to do arc secants. So I think that's pretty much it. Also, make sure you know how to do the integral of something like x squared times 3 to the x cubed plus 1 dx. So this is a to the x, integral of a to the x dx, which is going to be 1 over the natural log of a times a to the x plus c. In this case, it would actually be u, because we would rewrite this as a to the u du is 1 over the natural log of a times a to the u plus c. So using u substitution here, u would equal x cubed plus 1, and du would be equal to 3x squared dx. So you can see I can, x squared dx, I can substitute for du over 3. So you'd end up with 3 to the u du over 3. And then use this formula and you'd stick it back in. So make sure you know how to do the base other than e for doing integrals.